Today we're going to start talking about polynomial functions, but before we get into the meat and potatoes of this lesson, let's get some vocabulary down, starting with descending order. We're just going to place the exponents in decreasing order. Start with the highest one, go down from there. Make sure you're getting this vocabulary down in your notebooks. Leading coefficient is just the coefficient that's in front of the largest power. So even if it's not in descending order, you're just going to find whatever exponent has largest power, look at the coefficient in front, and that is your leading coefficient. And the degree is just whatever the highest power is. So if you have an x to the fourth and 4 is the highest exponent, the degree would be 4. So here are some examples. So I'm going to start off by just writing this polynomial in descending order. So I'm just going to look at the exponents, and I can see that this one right here has the highest exponent, so I'm just going to put that first. Negative 3x to the fourth. All right, so that one's out of there. Then I'm going to take this one, negative 2x cubed. That goes next. Then plus 7x squared. Don't forget the plus right here, that's crucial. And then plus 8x plus 19. So that is in descending order. So it's asking what's the leading coefficient. I'm just going to look at whatever the coefficient is in front of the term that has the highest exponent. So it's negative 3. So I could have gotten that even if it's not in descending order. And again, you're just looking for the highest exponent and then the coefficient. So then the degree is whatever the highest exponent is. So the degree here is 4. So here's one for, oh, nope, just kidding. I thought I had one for you to try. I do not. So let's move on. So now we're going to talk about graphing polynomials and just some different kinds of things that we would be looking for when we're graphing polynomials. So let's say I had a polynomial and I typed it into y equals in the calculator, and this is what it looks like. We're going to start talking about end behavior, something that you probably haven't seen yet before Algebra 2. And what end behavior is, basically, what are the x and y values doing? That's basically the gist of end behavior. And so I just want to point out a few things here. So if you can picture the x-axis, the numbers are, when you go this way, are getting really, 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 really high eventually. Okay, the numbers just keep increasing when you go this way to the right. And so eventually you would kind of think of it as the x values are approaching positive infinity. And so that's what this notation right here is representing. When x is approaching positive infinity, that's how you would say that. Then what are the y values doing? Well, looking at this graph, so we're just kind of follow along this graph. And as the x values are getting really, really, really large, the y values are going up. And so the y values are also getting really, really, really large. And so that means that the y values, so I'm talking about if you come up with ordered pairs all along this graph, the y values of those ordered pairs would be getting really large. Or another way of saying that is y is approaching positive infinity. So then when x is approaching negative infinity, when your x values, when now we're going to the left and your x values are getting really, 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 really small, we're going to look at what this graph is doing. So we're going to follow this graph along as it goes to the left, and we can see that it's going to keep going down. And so when we talk about that, we're saying that the y values, again, if we're looking at the ordered pairs, the y values of those ordered pairs would be getting really, 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 really small. Or another way of saying that is the y values are approaching negative infinity. We will certainly talk more about this in class, but here's another thing I want to talk about, and that's the number of real zeros. Okay, so the number of real zeros that we can see just by looking at the graph is how many times it crosses the x-axis, and we have certainly talked about this. So there's 1, there's 2, and there's 3. So there are 3 zeros. I'm hoping that you would actually be able to tell me the zeros if you look at this graph, but we're not necessarily going to get into that yet. So the number of zeros is 3. Now the degree gets a little trickier. And I kind of want to, before I reveal that, which it's too late, I already did, but I kind of want to just show you something first. So think of an equation with a degree of 1. We're talking about a linear equation. So just kind of picture what that looks like. A line. Oh boy. Okay. So as you can see, it does not change direction at all. This is increasing, another term that we're going to be talking about, but it's increasing, or a term that we have talked about is slope. The slope is positive. And so there's no change in direction at all. So we would say that if it is degree 1, the number of turns, I guess I want to say, would be 0. However, if we had something like a quadratic, which is degree 2, now we have something that looks like this. And so the number of times it changes direction, or to shorten that a little, let's say number of turns. Well, let's see. Right here, if you can picture Slope Dude right now, right here, he'd be going down. Okay, this is decreasing from left to right. And right here, it starts changing, and then it starts going up from left to right. So it's one turn, if you will. So if it has degree of 1, there's no turns. If it has a degree of 2, it's 1 turn. And so this pattern actually continues when we're talking about polynomials. So if we talked about a degree 3, there would be 2 turns, and so on. And so the degree is always going to be the, I guess this is one way of putting it, the number of hills and valleys plus 1. So if we're looking at the degree of this particular function that's graphed here, it changes direction once, twice. And so the degree is that plus 1. So the degree for this particular example would be 3. Degree is also the same number of solutions, but just keep in mind that there could also be, well, I guess if we're talking about polynomial functions, we're not going to be talking really about the imaginary solutions there. So here's one for you to try. Just take a look at the graph, and I want you to try to figure out what is the end behavior? What are the y values doing as x approaches positive infinity? What are the y values doing when x approaches negative infinity? What's the degree? Remember what to look for. You can certainly refer to the previous slide. And how many zeros are there? So now we get into this. Now this is Algebra 1 stuff, so I'm hoping you remember this. So I'm going to go ahead and let you try the easiest one on your own. Figure out what f of negative 2 is, and I'll go ahead and do number 2. So if you remember, what we're going to do is take everything that's in the parentheses and we're just going to substitute it everywhere we see x. So I'm going to have f of 2a is equal to 2 times a squared plus 7. And so 2a squared, hopefully everybody knows that that is 4 times a squared plus 7, and that's all we're looking for. So here's the last one for you to try. There's just one extra step, and that's multiplying it by 3 in the end. All right, so good luck. We'll talk about this tomorrow.